Hello everyone. In this video, we shall start from the mainframe basics and shall see the data movement which happens between mainframe to a new data store. The prime intention of this video was detailing the EBCIDC format and its conversion to readable character code, and also the movement of data, how exactly it happens and why it is required. The data movement from mainframe to a modern day database, why it is required. But without the basics, it may not make sense. So I'm starting with basics. I shall be covering the details in two parts. So part one would be more of a basics, and in the part two, I'll be covering some program which is written for this conversion. I have written a small program for the conversion from abstract binary to a readable format, and how that how that conversion happens. What is the philosophy behind the conversion and usage that we are going to see in part two. So we start as always with some key terms, hex editor. So if you have to see the binary data, the best way to see the binary data is using a hex editor. Hex editor is a tool that allows users to view, manipulate, and edit the binary data. So we shall see it, and as we see it, we shall know how exactly to use the hex editor. So if you have images, if you have binary data like EBCIDC format and even the ASCII format, everything in computer is binary data, zeros and ones. So how can you see that? You can use a hex editor to see the bits and bytes which are making that specific file. So that is hex editor. So character encoding. So there are different character encodings possible. One of the very famous character encoding is ASCII character encoding, and it stands for American Standard Code for Information Interchange. And now what is a character encoding? We are about to see that in some time. Text editors. So Notepad, TextPad, VI, all these editors, they are primarily reading some file for you, some bits and bytes, and showing you on a human readable format. So those are text editors. COBOL stands for Common Business Oriented Language, and it is the prime language for the mainframe. Developed in late 1950s, and it is still very relevant because in financial, government, insurance, banks, these places still COBOL is being used as of today. So that's where COBOL and the EBCIDC format is going to picture in this particular video. EBCIDC is again like ASCII. It's another character encoding, extended binary coded decimal interchange code, primarily used on mainframe computers. So now what is character encoding? So as we know, everything in computer is represented by zeros and ones. So if you have to see zeros and ones, you can't make sense of what those zeros and ones are representing. So character encoding provides a way for interpreting these zeros and ones. So this is a binary. We see the binary, and this is a readable equivalent. And this is where humans would be able to make sense of the data. They can't easily make sense of binary data. For example, in ASCII character encoding, this is a representation. This binary is a representation of character A. In EBCDIC, this binary is a representation of character A. So A is the same, but the encoding differs how the binary is representing that specific character. Now let's see the COBOL data types. So this is important because when we see copybooks, we should be able to know what are the important data types. It's not a comprehensive list, but still it gives you some details. So this alphanumeric characters, you can say pick X. If you have to give how many alphanumeric characters, you can put a number here. 9 is meant for digits, pick 9. Numeric characters, pick 9n. The length of the numeric characters is given by n. And for a Boolean representation, you can say pick 9 1, wherein if the byte is having the value 0, it is false, 1 it is true. Okay. And when we write the data structure, we typically use group items. So there would be a group 1. Okay, so group 1 is what? The highest level used for defining the overall structure is called group 1. Then the subchild imp ID, which is employee ID, which is what? If you see, pick 95. So it is digits, and length of the digits is 5. Same for this first name is a alphanumeric with 20 characters in place. Last name has 30 characters. Then there is a parent, which is employee address. And what are the components on it? Street, city, state, zip. So this is how the data types are represented in COBOL. Now let's see a simple program in COBOL. Just for the heck of it. I mean, we the intention is not to see COBOL programming, but how exactly it is written, a hello world COBOL program. So you have identification which you do. So identification identifies the program. So this identification division program ID, they are identifying the program. Then we have the data division. Data division section defines the data structures used in the program. In working storage section, you define the working storage variables. So which variable is being used in this program? User input. What is the data type? It's a pic x50. X was alphanumeric. So it is user input is a alphanumeric of size 50 bytes. Okay, now procedure division. This section contains the main logic of the program. So this whole section is going to contain the main logic of the program. So we display enter some text, user types some text which is accepted in user input, and you display the user input text, and then stop run ends the program execution. So very simplistic view of a COBOL program. Now copybook. This is the core of the whole video. So what is a copybook? Copybook is same like if you have to correlate, you can correlate it to the C structures in C. So copybook is a reusable piece of code that defines data structures, record layouts, and other elements used in COBOL programs. Copybook help maintain consistency and reduce redundancy by allowing you to define data structures at a single place. So in a copybook, you define and then you utilize that structure across your multiple programs. So this can be in Java, there is no concept of structure, but there is concept of classes. So in classes, you define all those entities which are to be used, correct? All the attributes. So those are, you can correlate those with a copybook. So this is an example of a copybook. Suppose you want to define a data structure for a customer record. So you can create a copybook named customer copy. Cust copy is the name which is given here. So identification, it identifies the program, and data division, this is where you define the data. So what it is defining? It is defining customer record, which has three children, customer ID, which is pic95, meaning it's an integer of 9 length. This is alphanumeric, and customer balance. Balance has total 12 digits, including two decimal places. Okay, so that's what is a copybook. Now, how can we use this copybook in our program? So uh, there is a main program, and you can utilize the copybook. So how? You can say this, and then you are able to use all those structures which were defined earlier. You are able to use them here. Okay, so this is allowing you to have reusability of the copybook which you created earlier, and you don't have to duplicate. So it is avoiding duplication and reuse. It is enhancing. Now let's come to one of the core things which we wanted to discuss in this video, which is mainframe data transfer. So there may be multiple reasons why you want to do mainframe data transfer. We shall not be going to the details of why we have to do, but in essence, mainframe is a old but still in use technology, still used in banks, finance, insurance, government organization, etc. So you may have to take this data from the mainframe for some purpose. Probably you want to move it to data center for data storage, or you want to take it to the cloud for data analytics. So for all those things, what you have to do, you have to get the binary data here from the mainframe, use some kind of secure data transfer mechanism. Here SFTP is being used, place it in some data lake. For example, in case of AWS, it could be S3. You can use it in some file stores also. And then this is where the core part happens. So this data which has come here, it is in the EBCIDC format. So EBCIDC is primarily not used when we are dealing with the modern day character encoding. So that's where you may have to convert this character encoding, and that conversion requires you to have copybook and the binary data. We are going to see the details of this part in a bit. So once you have done the conversion, you can put it in your data store, and then you can utilize this data for multiple use cases. Okay, so this part which is highlighted, we are going to elaborate on this. So yes, this elaboration of this part. So we have the binary data which we received in the data lake. Now what we are doing is we are we can convert this binary to character encoding. Okay, and how we can do, I would show a program in the part 2 where I would show how this encoding can be converted from binary to a readable encoding. And this readable data, again you have to have that what exactly this data means. This is a customer name, this is a date of birth, these are some other IDs. So those kind of details would be given by a copybook. So copybook is going to give you what? It is going to give you schema, and the binary data which you received is the binary data which you would read against the schema, and then in the database you would be able to have the data put in proper attributes which can be readable and which would make sense, and then you can apply all the new use cases in the data which you have collected from the mainframe. So EBCIDC character encoding. So this is the encoding. So in a in a byte there are 8 bits, and which can be represented by 2 hex. So one byte would be one character in EBCDIC. So if we see here, first hexadecimal digit is represented here and second digit is represented here. For example, if we have to see A, okay, what is A? A is first digit is what? C. This is the first digit. Second digit is what? 1. So if C1 if you convert to binary would be this. So if this is written 11000001 is written, you are aware that this is A. Okay, because that's the mapping from EBCDIC to the character coding. So this is A. Similarly, there are like for example, if we have to see some other thing, let's say I have to see question mark. So question mark is what? This is 6. 6F is the question mark. So like that, you can read what character means what. Okay. So that's the EBCDIC to character code mapping. Similarly, for ASCII also, we have a character coding chart, and this ASCII is primarily used in modern day computers. So that's where I'm showing this. I'm not showing UTF because Unicode is a big character set. It cannot be represented, but this gives the idea of what exactly character encoding is. So same character A, if you see, it is here. Okay, this is here, and if you see here, the hexadecimal is what it is. For A it is 4. This is the first character, first hex character 4, and 1 is the second. So 41, which is in decimal 65, or in binary 01000001. So if this data comes in binary, you know, if it is ASCII character encoding, then it is a character A. This concludes the part 1. I'll see you in part 2 again. Thank you.